Hi, welcome to my video on find the value of the derivative of f of the g of x at x equals c. And f of g of x means, again, you have a composite function, which you're going to use the chain rule. Number one, f of x equals x cubed, g of x equals 4x plus 6, and the h of x is the f of the g of x. Again, notice that I've written it down that this is a composite function. So the h of x is f. The g of x is 4x plus 6. So that means that the h of x, 4x plus 6, goes in the place of x in the f of x. So that becomes 4x plus 6 cubed. Now we have to find the h prime of negative 2. Well, let's go and get h prime first. So h prime, which is the derivative, and the derivative, this is a composite function, so the derivative of the function, so it's 4x plus 3 cubed derivative plus the derivative of the inside, which is 4x plus 3. So that becomes the h prime, f of h of x prime, and the derivative of this power is, I want to say, I seen the 4 there, 3 times 4x plus 3. So the 3 times 1 is 3, and 3 subtract 1 is 2. And the derivative of 4x is 4, and the derivative of 3 is 0. So the h prime of x becomes 12 4x plus 3 squared. Now we have to do the h prime at negative 2. So that means we fill in negative 2 in the place of x and work out its value. Remember, h prime is the derivative, and we're looking at the derivative when x at x is negative 2. So we have to simplify the inside first. So this is, we have to multiply first to get negative 8, and a negative 8 plus 3 is a negative 5. Negative 8 plus 3 is negative, I did a 6 here, and I got that's a 6, and that's a 6. I don't know why I put a 3 there, but I did, and I just noticed the error when I look back here. So that's negative 8 plus 6, and that becomes negative 2. So I made that little error talking too much, I suppose. So I did the inside. Negative 8 plus 6 is negative 2. Now I have the square first by PEMDAS, so that's a 4. So that gives me a 48. Number 2, the j of x is e to the x, the v of x is 3x squared minus 2x, and the k of x is the j of x bracket the v of x. So again, it's a composite function. So the k of x is made up of the composite functions of j and v. So the v of x becomes 3x squared minus 2x, and we put 3x squared minus 2x in the place of x in the j, so that's e to the 3x squared minus 2x. And we have to find a k at the derivative, which is the slope of the tangent at 1. So let's do the derivative first. So the derivative of the k of x, and again, this is the composite function, so it's the derivative of the main function times the derivative of the inside, so which is 3x squared minus 2x derivative. And the derivative of e to any power is the same, won't change. And the derivative of the inside is, so that's 3 times 2 is 6x, and derivative of negative 2x is negative 2. And that's we could simplify that, but there's not much, it's just right in front. So we're going to do the k at 1. So we're going to put 1 in the place of x. So we put 1 in. Just take our time. There's 1 going in. And 6 bracket 1 minus 2. So we have to do the exponent of the e first. So here we got to work out the power, so that's a 1. So that gives us 3 times 1 minus 2 times 1. And here we got to work out the inside of this, so we do multiplication before subtraction. Okay, and so that gives us e, so that gives us, we multiply first, this is 3, and that's negative 2. And we simplify inside the bracket to get a 4. And so that gives us e to the 1 times 4. So it's 4e. Works out to be, the derivative is 4e of this complex function using the chain rule. Okay, let's continue. We have another one, but this time I have 3 functions. So we got to do the composite functions of the d, of the f, of h. So let's put the h in just to show it. The h is 2x. So now the 2x h went in the f. So the f is tan f of 2x. F is here, so that becomes the tan of 2x. And now the tan of 2x is going in d, so that becomes tan of 2x, and it's the 4th power. So that could also be written as tan to the 4th power of 2x. But I just wanted to write both of these down to make sure you understood. So let's do the derivative. So that's what the, I got the d there, I got the g. I don't know where I got the g, but again, I didn't read my, oh yeah, I got a g. G is here. Of these composite functions, there's the g. So that works out to be, I got to do the derivative. Let's do the derivative at x first, and then we'll put the pi over 8 in. So this is now we have a power. So this is tan of 2x to the 4th power. We're going to do derivative. Derivative of the inside is the tan of 2x, and the derivative of the inside again, which is 2x. So we work outside in. We do the power first, we do the tan next, and we do the 2x. And that derivative, so the 4th power is 4th power of tan to the 2x being cubed. And the derivative of tan is secant squared. Derivative of tan is secant squared. So it's secant squared of the 2x. And the derivative of 2x is 2. Now to have all the chain rule done correctly, again there's 3 functions, so there's 3 derivatives. So the g of pi over 8, so that becomes 4. And we put pi over 8 in the place of x. We just take our time. Just be careful. And pi over 8. And this 2 times pi over 8 becomes, the 2 cancels, and I get a 4. So that's pi over 4. Cubed, secant. 2's cancel again, I get a 4, so that's a pi over 4 times 2. Now I could simplify that and make it 2 times 4 is 8, and so we're tan of pi over 4, and that's a cube, secant pi over 4. Now we have a pi over 4, and that's a pi over 4. Pi is 180, so it's 180 degrees over 4. So pi over 4 is a 45. So if we take pi and divide it in 4 pieces, 180 divided by 4 is 45. And we have we want a 45-degree rotation. Now I'm not going to make this a unit circle. I like to do it this way. I like to make the rotation 45, which is about here, let's say, which is pi over 4. This is the center of the circle. This is the rotation, 45 degrees. Drop a perpendicular to the x-axis. And I like to use the 45 as a 45 here. So there's a 45 in here with a perpendicular, so that makes that 45. So I like to go 1, 1, root 2, special right triangle. So the tan of 45, tan is opposite over adjacent, so it's 1 over 1, which is 1. So we have the tan of 45 to be 1 cubed. Just want to take that away, so do a little whitener there. I call it magic, just whitens it out, so won't make it confusing. Shouldn't do it, but I made that here, so I just white it out. Now we have to do secant, and secant is the reciprocal of cos, so secant is 1 over cosine. Cosine is adjacent over hypotenuse, so that means secant is hypotenuse over adjacent. So in relation to secant of 45, SEC, gotta be careful, squared, of the 45 degrees. So I got ahead of myself. So the secant of 45, sorry about that, the secant of 45 is hypotenuse, which is root 2 over cos, is the x, which is 1. So that's a root 2. So there's root 2. When I was writing this down, I was going to fill that in with a 45, but I didn't need to. I just had to find the secant, which is root 2. Now we simplify this. We do the powers first, 8. 1 cubed is 1. And root 2 squared is root 2 times root 2 is 2, which is root 4, which is 2. And that's 8 times 2 becomes 16. Sorry for that little error right there, but again, talking too much, I have a tendency to make an error. And if I find my error, I'm okay. So there's some more examples on using the chain rule and finding, doing the derivative. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content of my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.